Good afternoon. Thank you for joining us today. My name is Noah Dupes. I'm a technical applications engineer here at Spec Engineering, and I'm standing with the VP of Engineering at Worx. Worx is a brand of Spec Engineering, and the beautiful machinery you're seeing us stand in front of is a cooling wheel. Kevin, you want to tell us a little bit more about the cooling wheel?
Sure. A cooling wheel is nothing more than a device we use to cool primarily sugar-based masses.
Okay. What would that consist of exactly?
Sure. So that's going to cover fondants, icings, caramels. Even in some applications, it's been used for rice pudding. So anything you want to cool without having any additional shear or agitation.
What kind of rates would you get out of it?
Cooling wheels can be sized generally anywhere from 400 pounds per hour up to 8,000 pounds per hour.
And then temperatures, like I'm assuming since it's cooling down, does it cook up to a certain rate when it goes up to onto this cooling wheel and cool down? And what would that look like exactly?
So the only products that are going to be coming in contact with the product is going to be stainless steel or Teflon. So we're really only limited by the nature of those materials. So generally anywhere up to 350 degrees, cooled down to just above freezing.
Now, what is so unique or dynamic about the Worx model versus, say, other brands or other different designs out there?
So we use an internal water spray that sprays water on the inside surface of the drum. So that really prevents any hot spots from happening. So we have even cooling throughout the entire process. Additionally, we are an American-based company, so we manufacture these cooling wheels right here in the Chicago area. All of our support is based right here in Illinois.
Very cool. Well, can you walk me through a little bit of the design?
Sure, hopefully. So on your side of the machine, you can see the product hopper. That hopper is where the product will be discharged into, usually from a cooking vessel. From there, the product adheres to the surface of the drum as it rotates on the outside. So the product will be on the outside of the drum, rotating around. It's going to be a pretty slow rotation, about 1 RPM. And by the time that product has reached all the way to the scraper where on your side of the machine, it has been cooled down to its target temperature. So as it's riding around, it is cooling, and then once it reaches the scraper, it is ready to be discharged to the next step of the process.
Now, that sounds like it's something that needs to be very accurate. How exactly do you keep track, and what exactly do you control in terms of temperature?
A wide-ranging list of temperature sensing devices, whether it's an RTD or an infrared sensor. We can use that along with some very accurate PID tuning from our controls department, where we can bleed in cooling water to hit our temperatures within a degree.
So Kevin, you brought up a little bit about the temperature control of the system and how we use basically the cooling system. Can you walk me through how the heat exchanger and everything works?
So what we're really trying to do is reduce the product temperature. So using a temperature transmitter or an infrared transmitter, we can measure the temperature of the product and adjust the cooling water so that your product is discharged from the cooling wheel at the right temperature. Over here on this side of the machine, you can see the chilled water pump. The chilled water pump is going to extract the water from the inside of the drum. It's a self-contained loop, so we need to get that water out. It's a self-priming pump. From that pump, it is pumped through our heat exchanger. So on our side of the heat exchanger, we're only sending our water. On the customer side of the heat exchanger, they're going to be sending their plant's water or their self-contained chiller water. From there, the chilled water is sent to the other side of the drum and sprayed on the inside. So the entire surface of the drum gets a spray of a very consistent water temperature.
And how accurate is that temperature typically?
We can usually control our discharge temperatures to within a degree.
Do you maintain a temperature inside of the cooling wheel and then for a desired temperature to get off of the cooling wheel?
That's right. So we're using a completely self-contained water cooling loop. So the water inside this drum is completely separate from your plant or chilled water system.
Awesome.
By metering in that cold water into our heat exchanger, we can very accurately determine the surface of the drum.
Now the heat exchanger, I'm assuming, is over on this side.
Yeah, it's right over here on the back side. It is downstream of our chilled water pump. So that is a self-priming chilled water pump that sucks the water out of the bottom of the drum and sends it through the heat exchanger to be sprayed on the inside surface.
Very cool. Very cool. And now, what kind of end product could you expect to get out of the cooling wheel? Like, I know you mentioned fondant, chocolate. Is there any sort of special applications that this has been used in the past that other kind of designs, maybe the cooling that besides the cooling wheel?
So the cooling wheel is really going to be it's the heart of a continuous fondant machine. Most people might see this and recognize it as part of as a fondant machine. So if you put it together with a vertical heat exchanger, or if you put it together with a continuous vacuum cooker, you can make hard candy. So you can use this piece of machinery to cool a wide variety of products.
Very cool. Can you tell me a little bit more about what other things Candy Worx can add in conjunction to this as far as a complete system?
Sure, so I mentioned the fondant and hard candy, but we can also do some chocolate belt coating through our Revolve line. We can also do depositing through depositors through our recent acquisition of Bottom Line Technologies. Cool. We can also do some other things around hard candy forming and shaping. We can really be a full engineering solution to a confectioner.
Awesome, sounds good. Thank you for your time, Kevin. Appreciate it.
Of course, thanks.
Take care.